Okay, so let's continue with what we left off today. Just a quick recap. So this week we're mainly talking about string, and you have learned string before, which is used to encode special characters, spaces, digits, letters. Basically, it represents text. And we have learned that you use index starting from 0 if you count from left to indicate the positions of a particular characters in the text. And if you want to count from the right to left, you use -1 starting from -1, and then -2, -3, and so on. And then we have learned about slicing. It works the same as list. And then we learned some of the methods on strings. And notice that all of these methods here, if they are used, for example, to change the elements in the string, it will not change it in place. In contrast to list, there are methods that will change in place, which means you change exactly the list itself rather than create a copy. But for string, anything that you want to make changes, you create a new copy. Okay, but that's what we call string is immutable. You cannot change the elements in text. If you want to change it, you basically have to create a new copy with that changes effect. Okay, and then we learned about string internal representations. So every characters has its own internal representation as integers. For example, capital A through Z are from 65 to 90. Little a through Z are from 97 to 122. And we have learned one use cases where instead of writing A to Z explicitly, we write a for loop on range from 65 to 91 so that it includes 90. It will, each of these integer representations can be mapped back into its corresponding character using CHR, okay, which is the inverse of the function ORD. So ORD take a character and returns the corresponding integer representations. CHR is a function that take the integer representations and returns the corresponding string, okay? So you don't have to remember explicitly what is A through Z or little a through Z. If I ask you to do this in exams, it will be given to you. All you have to do is to write a for loop from 65 to 91 so that it includes 90. And if you want from little a to little Z, you need to write a range from 97 to 123 so that it includes 122. Okay. Now today, we're going to learn that one examples of where you want, if you remember, for list. Let's see. We have learned one method of how to remove an element from a list. Okay, so we have learned that there is a method called remove, which removes the first occurrence of these elements that you want to remove. Okay, so you use, for example, list.remove to remove the first occurrence of value. And then we proceed to extend this to remove all occurrence of the elements from a list. Okay, now can we do the same in string? Okay, can we remove some elements in string? For example, one use cases is that if the string contains, for example, things that you don't need, dot, which represents arrows, or when messages are sending through, there are some missing pieces that are represented using hashtag, for example, you want to remove those unwanted characters in your string. So can we do the same just like list, where we can, in list, we can remove the elements using the method l.remove. And now can we do the same? So before you try, you need to check all the methods available for string. So in this case, there is no remove. Okay, you have something called remove prefix and remove suffix. You can check it out yourself. That's not what we want. Okay, but there is no remove here. So what can we do? Okay, so this course, I don't want you to remember all these methods that are available, because for different programming languages, you will have different methods available to you. What I wanted you to learn is the ability to use existing method to help you to solve your problems. In this case, we don't have a built-in method called remove, but we have something called replace. Okay, so let's see if we can use replace creatively to help us to solve our task, which is to remove an element. Okay, so it has string.replace, and let's see what it does. It takes an old string with and then a new string. It returns a copy of all occurrence of substring O replaced by new. Okay. In particular, this O here can represent just one character because it's a substring. Okay. So let's try this out. For example, say text equals to say A dot B dot C. Okay. So this is my text A dot B dot C, and I want to remove. So I want to replace dot by say hashtag. Okay, so I'm going to use this built-in method here. So I'm going to do text.replace. So if it's a method, you always know that you can use it on dot. Okay, dot on some object. So dot replace, what does it need? It needs something that you want to replace of. In this case, it's dot. We want to replace dot with the new substring or new character, hashtag. Okay, so let's see. Now, every single occurrence of dot is being replaced by hashtag. Okay, so replace basically apply on a string. So text is a string, it apply on the string, and then it take two string, these are substrings, it replace every occurrence of this with this. Okay, so now what can we do if we want to replace or if we want to remove it? Okay, so to remove an element, say dot from text, okay, we're gonna creatively, so we replace dot with an empty string. Okay, so let's try this. Suppose I want to remove this. I want to remove dot. Okay, and I don't have dot remove method, but I have replace. So I'm going to be very creative here. So I'm going to replace dot basically with an empty string. All right, and let's see what we get. So every dot now is replaced with an empty string. It's the same, the effect will be the same as I remove this dot here. Okay, so this is the idea of how to use existing built-in method. It doesn't seem to be doing what you want to do, but if you're being creative in using this built-in method, you can get it done using the built-in method. Okay, however, very important is to know that string is immutable. Okay, the method dot replace create a new copy of string with all occurrence of old string replaced by new substring. Okay, so every single time you encounter a dot, it will create a new string and replace it by an empty string. Okay, so the fact that string is immutable, okay, so the fact that string is immutable makes it inefficient to replace or remove some elements in the string. Because every single time you make a replacement or you make a changes or you make a removal of some elements or update, okay, or replace or change every elements in the string, you create a new copy. So if you have many dots here, you create many copies of this text every single time you replace it with whatever that you want to replace. Okay, so you have 10 dots, you end up creating 10 strings and only take the last strings, for example. So it makes it very inefficient. So is there a way to not creating every single step where you replace it, you create a new string? Now, string is immutable, so we can't do that. But we know that list, for example, can be replaced in place. Okay, so if you are to write an application or a program that requires you to make changes to the string frequently, okay, so the best way is to first convert it to list. Okay, so the idea is that I have text list is equals to, you convert it into list using typecast text. Okay, say I have text here, equals to say dot b dot c dot d dot f dot, and so on. Okay, so I first convert into list, and let's look at our text list here. So now it creates a list of all the characters. Every single characters in text are inside the list now. Okay, now you have this list here, and you only work on this list. Okay, whatever you want to do, whatever changes that you want to make, you change it over this list here, and then you only convert it back to string. In this case, you avoid having to create multiple strings intermittently that make the changes. Okay, so in this case, I can, for example, run the for loop over this text here, and every time I encounter a dot, I replace it, for example, with the empty string. Okay, so for I in range of text list, okay, and I'm going to do that if text list of i's is equals to the dot. So if this is dot, I'm going to replace it with an empty string. Okay, so what do I do is that I change text list I to equals to empty string. All right, so basically I go through every single element here in this text list, and at every single iteration I check whether this is equals to dot. If this is not equals to dot, I don't do anything about it, it remains intact. And then I go to the next one. If this is equals to dot, I assign a new value to it, which is the empty string. Okay, so let's see what do we get in the end. Let's see. Oh, okay, tell me, what is the error here? How can you solve this error? It says that list object cannot be interpreted as an integer. So text list is a list. Range take integer value. Okay, what should this be replaced with? We're gonna go through every single element in text list. So this I here represent the index. Okay, so what we really want is the length of text. We're gonna start iterating from I equals to 0 all the way, but not include length of text list. Okay, so this will iterate through 0 all the way to length of text list -1 inclusive. Okay, so it will not include length of text list, it will include -1 of this element here. Okay, so this basically iterates through all the indices. All right, so now you can see your text list here have all the dot replaced by an empty string. Okay, and we are still working on one list. Okay, we did not create new list. This is the same list, the same text list. Okay, now, and then we're gonna put it back. Text equals to, now we're gonna convert it from list to string. Okay, so let's see. So if you have string, so if you have list, can we do that? So let's see, if I do string text list, what do I get? If you do, so earlier on, when I want to change the string or convert the string to list, I just use typecast. Okay, and then I will have every element, every character in text being stored as an element in a list. Now, if I want to convert this back to string, can I do that? If I do that, if I use typecast string text list, what I get is that the whole thing is put as a string, but it's not what we want. We wanted it to be A, B, C, D, E, F without the dot. So this is not what we want, okay? So we're gonna write it down. To convert text list into string, okay, in such a way that all elements in text list are joined together. We can't use just typecasting. Okay, we can't use just that because it would literally take the whole list and put it as a string. It's not what we want. Okay, we want such that all of these elements are joined together to become one string. Okay, what we really want is that all characters in text list to be joined together as one string. Okay, that's what we want. So we're going to use a method. So if you type dir string, you check whether there is something called join. Okay, so let's see what is this join about. So let's do help string.join. Okay, so again, it says that it can contain any number of strings. All right, so what this means is that even give you an example here. Okay, so it takes a string, all right, dot join a list of strings. Okay, what it does is that it's gonna join every single element here, okay, together, but with a dot. So for example, you have a list of here, A, B, P, Q, R, S. You're gonna join them together, A, B, followed by a dot, followed by PQ, followed by a dot, followed by RS, okay? That's called join. So we're gonna use that in our example here. So we have text list is here, and we're gonna join them together. So what we're gonna do is that now text is equals to, instead of dot, we are not putting dot back. We're gonna replace it with a dot, with just an empty string, join text list. Okay, so recall your text list is this. So what it's going to do is that it's going to join A with an empty string, join with an empty string, and then with an empty string again, and then with B, and then empty string again, and then empty string again, and then C. Essentially, you join all the characters here. Okay, so let's print text now. And you have what you want. You basically replace or remove the dot with an empty string. Okay, so this is the final procedure that you're going to do. So let's summarize. So in summary, so summarize here. So we have some text that we want to remove and summarize. So suppose we want to remove dot. Okay, you first convert it to list. All right, because we're going to make a lot of changes here. Every single dot is going to replace or remove. Every time you make changes, you create a new string. And if you have many of these changes, you will have create many of these strings, which of course is not ideal. So if you don't want to create this new string every single time you make changes, you make it into a list first, okay? And then you work only on the list, okay? Because the lists allow you to change element in place. So you create one list and everything you change is in this list. It's exactly the same list, but you make changes in place, okay? And then now, after you make the changes, only you convert it back to string using joint, like what we have discussed, okay? So now I join them and assign it to the value text, and I will get the final value, okay? So that's the idea of how to interchange between list and string. So if you are working on string that you know that you're going to make many changes, you first change it, convert it into list, make changes over the list, and then after you have completely satisfied with the changes that you want, then you convert it back to text. In this case, you only create 3 data structure. One is an original string, second is a list, and third is back to the string. Okay, if you don't do that, if you change it every time you see dot and you change it, you create multiple copies of text with that change effect, and that's creating a lot of strings. Okay, so this is the most efficient way to make changes to string if you have to do it multiple times. Okay, now so far we have learned about all these strings and these. Are there any other data structures? So let's look at a remark. So there are actually many data structures, and they support different things. Okay, they support different operations, different things. For list, for example, it takes any types and they store it like a container. And it supports, for example, changing things and retrieving things, slicing, reversing, sorting. Text string, on the other hand, it supports also similar things as list, but it only takes characters. It doesn't take every single element is of string itself. Okay, if you want to convert into int, you have to take each one of them to become an int. And also, it does not support changing. Every time you want to make change, you basically create a copy. Okay, so there are many different data structures that support different things. So one thing you have to understand is that when we do search over the list or string, okay, we essentially iterate through the elements. Okay, so if the element does not exist in the list of string, you basically, if the target element is not in there, in the list or string, okay, we basically have to check every single element in the list or string. Okay, so if you have n elements, you basically examine n elements. If you have 1 million elements, you basically have to examine 1 million elements. So if you are looking for fast searching, okay, so there is another data structure called the set, okay, which allow fast searching, where it doesn't take much time. So it doesn't take into effect of how long it takes, how large is the set. Okay, so if you have a list of 10 million elements, you basically have to look through each of these 10 million elements. But for set, so essentially your running time is based on the length of the list of the string. But for set, it's a different data structure. It allows very fast searching because when we store element as a set, it stores more than just the element itself. It stores what we call the hash value. So for each of the elements that's stored in the set, it creates another thing that allow us to do fast searching. Okay, so with this is beyond the scope of this course, but I just want to point it out. There are data structures that allow you to do fast searching, for example. Okay, however, the downside of set is that it doesn't store duplicated values. Okay, so for example, it won't be useful for our use case of quiz. All right, so for example, quiz, you're to store the score of each of your quiz. Okay, suppose your score of quiz 0 is 5, the score of quiz 1 is 3, the score of quiz 2 is again 3. But if you store it as a set, it will remove the 3 because it occurs twice. Set only store unique values. Okay, so it really depends on your applications. What do you want to do with this? For quiz, for example, we want to store every single element, whether it is duplicated or not. We want to be able to retrieve these elements based on index. So we store it as a list. Even though if we have a large list, we're going to incur a large running cost of searching. Okay, but if we just want to check whether an element is in the list, for example, say you have a password, okay, and suppose your purpose of using this password is to check whether, or maybe password history. Okay, password history will store all the previous password. For example, suppose this is your first password, this is your second password, and third password, okay, etc. Then you can use it as a set because I don't need to know when do I store this password, when did I make a change, I don't need to know. All I need is that I need all of them stored as a history so that in the future, what I need to do is to search whether I have already used this particular password in this history. Okay, so if your use cases, okay, so it depends on use cases of which data structure to use. Okay, so for the applications of maintaining score of quizzes, we cannot store it as set. Then we lose all these duplicated values. Okay, so we have to use list so that we have all the score for each quiz, okay? Even the duplicate, even if the score appears many times or more than once, okay? If we store it using set, we lose some of those, all right? And in the applications of, say, maintaining password history, okay, where the only purpose is to check if a particular password has been used. That is, if the particular password is in the history. Okay, so in this case, we don't need to know which which password comes first. We just need to check whether it exists inside the password history. All right, in this case, we can store it as set. Okay, so when we want to check, for example, you create a new password, say ABC, and you wanted to know if this password you have used it before, you just use password in password history. Okay, this will be really fast. It's just basically checking whether passwords is in this set, and this set support very fast searching, because when you store it as element in a set, they do some pre-processing. All right, each string here, they also store something else. They call a hash value, which is sort of digest version of this string that allow you to do fast searching. Okay, you will learn this in the advanced course. So really, it depends on what use case that you want to decide which data structure to use. Now, one other things that I want to mention is that we often also require to create our own data structure. For example, you have a graph. So the graph represented by nodes, right? Each node, you should also indicate the number of edges connecting to this node to which node. And this will require, we don't have an existing data structure that support this, so you can create your own data structure. And of course, this is beyond the scope. But what I want you to learn today is the ability to use existing data structure to support what you want. For example, if you look at your grade system, the lab, okay, in the lab, we talked about this individual grade system here. Let's see. Individual student grade system, okay, where you have this grade system, you initialize every single quizzes to 0 first at the beginning, and suppose you have 12 such quizzes, okay, and you want to create such an individual grade system that maintain, update, and compute the final scores, okay. So we have a versions that we update the quiz score. So every time after the quiz, we discuss on Monday, you collect the quiz, and then you look at the quiz number, you can update it. So you have a version where you update the quiz based on the quiz number. And then this quiz here will store for each student. So this quiz here is correspond to each student. Each student will have your individual list of quiz, 12 elements in there, initialized to 0 at the beginning. And then every single time after you take the quiz, you update it accordingly. And at the end, you can have a final way to, you have a final total score by computing these final scores, okay? And we have already seen this during the lab. You first sorted it, take the slides, take the maximum 10 of the quiz scores, and then compute the final total score, okay? That is for individualized quiz. For each student, you have your own quiz, okay? You have your own quiz list. So remark, okay? For each student, you will have your own individual quiz list, okay? That's from your standpoint of view. All you need to do is to update the quiz score, compute the final value so that you know what is the final quiz score that contribute to the final marks. But from my point of view, or from the teaching team point of view, okay, for teaching team, okay, what we need to do is not just one student's quiz. we need to keep track of all the student quiz, okay? So we need to keep track of all students' quiz scores. So again, we need a way to store each individual student quiz score, okay? And then we do some manipulations, we update the things, or we find the best students, or the top 10% or the lowest 10%. So we want to have a way to maintain all the students' quiz scores. And so we need a data structure. Okay. So what data structure do we need to maintain, update, and analyze all student scores? Okay. Okay, in particular, if I want to know, for example, a student's particular quiz score, I need to be able to do that. And if I want to know the first half of the students, I need to be able to do that. So what kind of data structure we need? So we have learned list and we have learned string. And we have said that quiz, we use list, and string, we use it to store text. So what can we do? So we need multiple of these. So one thing that you have learned, and there are many other data structures that support this, instead of telling you more data structure that you need to learn, I want you to think what you can do with whatever that you have learned so far. You have learned list and string. So most likely we're gonna use list. Okay, so we're gonna use class as a list. Okay, and for each of the students is identified by an index, right? So I will have each of these quiz here. So suppose I have only 5 quiz, okay? So I have 5, 3, 2, for example. And maybe I only have 4 quiz. And some of the students, and so on. And just a couple of students, for example. Suppose I have only 3 students. Okay, so this will be the score of student. This will be the quiz score of student with the index 0. This will be the score of the student with index 1. And this will be the score of students with index 2. Okay, so basically what I created is a list of lists. Okay, so basically list of lists. So it's basically still list, okay, but individual element now is a list itself. So this is called list of lists. Okay, it's nothing new. You know exactly how to deal with list of lists because you just treat each of them as just an element. Each individual element is just a list itself. Okay, you know everything you know about list for now that you can use it to do this problem here. Okay, so you just think of this as just one element, think of this as a second element, and think of this as third element. So if I run this, okay, class is not a good, okay. Let's look at this error here, syntax error, invalid syntax. So this is what we call a keyword. Class is a keyword, okay? Class is a keyword in Python. So I shouldn't use class, I just use class scores, for example, okay? So class is a keyword. So we can't use it as a variable, okay? So we have class score is equal to this. And if I do length of class scores, okay, this will give me 3, all right? Because each of these lists here is one element inside this big list here, okay? So if I want to know, for example, if I want to retrieve quiz scores of student with index 0, so what I do is do class scores, square bracket 0, and it will retrieve the first element of this class scores here, which is 5320. This represents the quiz score of the student with index 0. Okay, now if I want to retrieve quiz score of quiz number, say 0 of student with index 0. Okay, so class scores 0, square bracket 0 will give me the student. So the student quiz, student 0 has this quiz score here. Okay, this is the student 0 quiz score. Okay. All right, if I want to retrieve the score of quiz 0 of this student, so what I'm going to do is that I'm going to print out student 0 square bracket 0. This will retrieve the first element of the quiz of this student 0 here, okay, which is 5. So essentially, when you want to retrieve a particular score of a quiz number of a student with a certain index, what you're going to do is to create 2 brackets. Okay, so say want to quiz number j of student with index I, say I is equal to 0, j, say if I want to know the quiz number 3. Okay, so what you do is do class scores. Okay, so first is the index number, student with index 0. Okay, index, student index. Okay, and the quiz number j of a certain quiz number. Okay, so this is your quiz number. Okay, so you go to class score, which student first? Okay, the first index represents which student first, so student index, followed by the quiz number. Okay, so the first bracket will retrieve the score, quiz score, the whole of that particular student with that student index. And then if you want to know the particular quiz score of that quiz number of that particular student, you have another bracket. These will retrieve the quiz, the element at the index, which is equals to quiz number of the class, of the students. Okay, so I have here. All right, so it's equals to 0. If I want to create, for example, 2, this is 2. Because if you look at here, student 0 have index, this is the quiz score of student 0. Okay, and this is index 0, 1, 2. So when look at quiz number 2, it has score of 2 here. Okay, so this is the idea of using list of lists. Okay, so you know everything that you need to know about list. In this case, the same of list of lists. You just treat each of these lists as an element inside the list itself. Okay, now that's all for today. We're going to do the quiz for today. Thank you, class.